Now we are going to learn theorem 10.6. Equal chords of a circle are equidistant from the center. What do you understand by equal chords? Chords of equal length. Chord AB and chord CD. If they are of equal length, if they have same length, then they are equidistant, same distance from the center. That is, if AB, chords AB and CD are equal in a circle, then they are equidistant, that is D1 equal to D2, equidistant from the center, same distance, D1 and D2 are equal. How can we prove this result? If given that AB equal to CD, we want to show that D1 equal to D2 or OM equal to OM. To show this, join AO and BO. Here AO and CO. AO and CO. Equidistance, same distance by this distance from the center to the chord means perpendicular distance from the center to the chord, and it is the shortest distance to the chord from the center of the circle. So distance, equidistant, distance from the center to the chord means shortest distance or perpendicular distance. Perpendicular. So this angle, that is OM is perpendicular to AB. Similarly, ON is perpendicular to CD. Now how can we prove this result? We are given AB equal to CD. Then what is AM? AM equal to half AB. AM equal to half AB. Reason? Perpendicular from the center to the chord bisects the chord. Previous theorem. Perpendicular from the center of a circle to the chord bisects the chord. That is, these two are equal. AM equal to BO. So AM is equal to half AB. Then what about the CN? By same reason, CN equal to half CD. AB equal to CD. So half AB equal to half CD. That is, AM equal to CN. AM equal to CN. Since AB equal to CD, half AB equal to half CD. That is, AM equal to CN. Now, angle 1 and angle 2. Angle 1 equal to 90 degrees equal to angle 2. Reason? Perpendicular distance. Perpendicular distance. Now what about AO and BO? AO and CO? Are they equal? They are equal because they are radii of the same circle. Radii. These two are also equal. And they are hypotenuses of the right angle triangles AMO and CNO. Hypotenuses. Why? Because they lie opposite to the largest angle, 90. They are opposite to, in the right angle triangle, the side lies opposite to the largest angle is the hypotenuse. So these are the hypotenuses also. So what about these two triangles? Triangle AMO and triangle CNO, they are congruent because RHS theorem, right angle hypotenuse side of one triangle are congruent to the corresponding chords of the other, are equal to the corresponding chords of the other. So these two triangles are congruent. So what about MO and NO or D1 and D2? They are equal. Corresponding chords of congruent triangles. So to prove this result, just for understanding, AB equal to CD. So half AB equal to half CD equal to that is AM equal to CN. Angle 1 equal to 90 degree equal to angle 2. Then AO equal to CO. See, radii of the same circle. So triangle AMO is congruent to triangle CNO RHS. So D1 equal to D2. That is, if the chords are equal, they are equidistant from the center of the circle. Now what again gives a converse? If the distances are equal, then the chords are equal. How can we prove this? If the distances are equal, then this is theorem. The converse of this is theorem 10.6 is theorem 10.7. If the theorem 10.7, if D1 equal to D2, then AB equal to CD. AB equal to CD. For that, consider the same figure. We are given D1 equal to D2. We want to show that AB equal to CD. D1 equal to D2. These two are equal. What about AO equal to CO? What about AO and CO? They are equal. These are also equal. Then these two angles are 90. So then these are the hypotenuses. These two angles 90, perpendicular distance. So by same rule, RHS, right angle hypotenuse this side, not this side, this side. So right angle hypotenuse and this side are equal. Are equal for the congruent triangles. So these two triangles are equal, congruent triangles. Then what about AM and CN? Then AM equal to CN. AM equal to CN, corresponding chords of congruent triangles. Corresponding chords of. But what about AM? AM is half of AB. AM is half of AB. Perpendicular from the center to the chord bisects the chord. So AM is half of AB. Then what about the CN? CN is half of CD. Half of AB equal to half of CD. Then AB equal to CD. AB equal to CD. So if D1 equal to D2, D1 equal to D2, if that is chords of same distance from the center are equal. Chords, two chords of a circle. If the chords are equidistant from the center, then the chords are equal. If the chords are, theorem 10.6, equal chords are equidistant from the center. If the chords are equidistant from the center, then they are equal. Theorem and proof, just for understanding. So remember this. Read textbook pages 176 to 178. Then do example 2 and the then exercise 10.4. Thank you.